And another question states that M is equal to 4, 5, then 2, 3. That is a matrix, a 2 by 2 matrix. It has 2 rows and 2 columns. So this is a 2 by 2 matrix where the number of rows are 2. This is the first row and this is the second row. And 2 columns, the first column and the second column. So this is a 2 by 2 matrix. So that the first value represents the number of rows and the other value represents the number of columns. So this is a 2 by 2 matrix, that is M. Then we're told that also N has been given, and the matrix N is given as -2, 3, 1, -1. This is also a 2 by 2 matrix where there are 2 rows, the first row having -2 and 3, and the other row having 1, -1. And the columns are 2. The first column is -2, 1, and the other column is 3, -1. So those are 2 by 2 matrices that we've been given in the question. And you're told to find, you've been told to find, I think you can be able to see clearly, you've been told to find M -1, as you may read in a locally appropriate way. So M -1n, that means you'll first have to find the inverse of matrix M, then multiply that answer with the matrix given as N. That is what it means in a mathematical language. Find the inverse of matrix M, whatever you get, multiply with matrix N. You're going to get the answer you've actually been told to provide in that question. So they're all 2 by 2 matrices. So you'll first have to find the inverse of this. So of course, these values are actually not numbers. They are referred to as elements. So the elements in this matrix are 4, 5, 2, 3. The elements in the other matrix are -2, 3, and then 1, then -1. So let's kick off and first get the inverse of this matrix. We shall first have to come here and get the determinant. So how do you get the determinant? We have to actually pick the elements of the main diagonal, get their product, then minus the product of the elements in the secondary diagonal. So come here and then say 4 times 3. I'm first getting the inverse of matrix M, then multiply the answer with matrix N. Okay, that's what we need to have any change getting done onto it. So this 4 minus, you see, so it is 2 times 5. So we shall have 12 less 10. So the determinant is 2. Product of the elements in the main diagonal less product of the elements in the secondary diagonal, or the second diagonal. So the determinant is 2. So the date is 2. After that, we'll proceed to then have this. We assume this is over 1. Get its reciprocal, 1 over 2. We shall say into. You see, we'll come here and then change the position of these elements in the main diagonal. We shall have 3, 4. Then in the secondary or second diagonal, we change the signs on these elements. The elements have their signs changing. They are all positive, that is positive 5 and then positive 2. They'll change into this other form, -5, -2. So make sure you don't actually change their positions, only change their signs. If they're all positive, let them all become negative. If they're all negative, let them all become positive. If one is negative, let it become positive. If the other one is positive, let it become negative. We can decide to open the brackets, no problem. So half of 3, that is going to be 1.5. Then a half of -5, that is a half times -5. That gives us -2.5. A half of -2, that is -1. A half of 4, that is 2. So this is the inverse of matrix M. So M inverse is going to be -2.5 on this end, 1.5 on this other end, -1 on this end, then 2 on that other end. So then we need to have the inverse of matrix M multiplied by N. So that we shall end up having 1.5, -1, -2.5, 2, and this is multiplied by N, which is -2, 3, 1, then -1. Correct. So we need to get the product of this. So we'll start 1.5 times -2, then -2.5 times 1. We have to actually draw a 7 when elements in the two matrices are getting multiplied. So you have to actually make a 7. So the first one and the first one, and the second and the other one just below it. The first and the first, the second and the one below it. Okay, so 1.5 times negative 2, that is negative 3. Okay, negative 2.5 times 1, that is going to be plus negative 2.5. That is done. Next, again 1.5 and 3, then negative 2.5 and the one below it. So we shall have 1.5 times 3, that is 4.5, plus negative 2.5 times negative 1, that is positive 2.5. Okay, let's come back to this. The first and the first, the second and the one below it. So negative 1 times negative 2, that is just 2, plus, then 2 times 1, that is just 2. Okay, this and the first, this and the one below it. Negative 1 times 3, that is 3. Then 2 times negative 1, that is negative 2. So negative 3 plus negative 2.5, that is negative 5.5. Okay, then 4.5 plus 2.5, that gives us 7. And 2 plus 2, that is 4. And 3 plus negative 2, that is 1. So that becomes our final answer in as far as the inverse of matrix M multiplied by N is concerned. That gives us the final answer for that question.